In this video, we'll be learning how to write functions that contain horizontal and vertical stretches and shrinks. By definition, a stretch or a shrink is a transformation that will either stretch the graph to be taller or shrink the graph to be shorter. And there are both vertical and horizontal stretches and shrinks. These are the types of transformations that actually resize the shape rather than just moving it around or flipping it over. So far in this class, we've already talked about what are called vertical stretches and vertical shrinks. And what you hopefully thought of immediately was the fact that a vertical stretch or a vertical shrink is impacted by an A value. So as you take your notes for this particular slide, I would note that we have our equation right here where it's very similar to our reflection equation, where if we vertically stretch or shrink an entire function, we're going to multiply the outputs, all of them, the entire function, by our A value on the outside. So notice that it's very similar to when we vertically flip our graph. We're going to multiply the entire function by a value, and in this case, we're going to multiply it by A. Now, on the flip side of this, in addition to having vertical stretches and vertical shrinks, we're also going to have horizontal stretches and horizontal shrinks. And this is going to be a new letter for us in Algebra 2. So notice here that if we have a horizontal stretch or a horizontal shrink, it's represented by this letter called B. And this will be a letter that from here on out, I will expect you to know and associate with horizontal stretches and shrinks. And very similar to a horizontal flip, this B value multiplies the X value on the inside by a value. Now, what is very, very tricky about this, and what you have to keep in mind, is if you read in here very, very carefully, it says the graph of y equals f b of x is a horizontal stretch or shrink by a factor of 1 over b. So as you read the instructions on the next page, you'll be told something like, you have a horizontal stretch by a factor of blank. And they'll give you a number, and they'll say it's a horizontal stretch by a factor of blank. So our factor of blank isn't going to be directly our b value here. What we're going to have to do is take the reciprocal of our factor, or 1 over whatever factor they give us, and that will, as a result, be the b value that we then multiply by x. So I know that probably sounds a little confusing at the moment, but as we dive in and do some examples, hopefully that becomes a little bit more clear. So as we did in the previous two videos, we're going to again use the same functions, and this time we're going to be performing vertical and horizontal stretches and shrinks. So here in example A, it says write a function g whose graph is vertically stretched by a factor of 5. So we're taking f and we're vertically stretching it by a factor of 5. Now, just like before, we're going to rewrite this one a little bit differently, and we're going to rewrite it so we can see our h and our k values. So we have x plus 0 plus 1. Now, we are vertically stretching by a factor of 5. So remember, this means that our a value, we're doing a multiplication of 5. We're going to take every point on that graph and we're going to make it 5 times taller. And remember from our instructions, we saw that this is calculated by taking y equals a times the entire function. So what we're going to do here is we're going to take this entire function, so we have 2x plus 0 in parentheses plus 1, and we are going to multiply it all by our vertical stretch factor of 5. So because this is a vertical stretch, we're going to multiply the entire function by 5. And just like we did with the reflections, you're only going to distribute it to each little chunk. So there's a chunk of stuff grouped together, and there's a chunk of stuff grouped together. So as a result, here we find g of x is equal to 5 times 2 is 10 our x plus 0 stays, and then we have 5 times 1, which is 5. So the biggest thing to notice here is notice that that coefficient in front of the parenthesis or in front of the x, that ultimately was multiplied by 5, as was our k value out back. So both items were multiplied by that vertical stretch value of 5. Now if we look at the second example here, it says write a function h whose graph is horizontally stretched by a factor of 2. Now remember, when we looked at the notes on the previous slide, we're going to take some value b and multiply it by x. But remember, b isn't just 2 in this case. Horizontal stretches work a little bit differently. So in order to calculate what our b value is going to be going to be equal to 1 over our factor because they are reciprocals of each other. So in this case, our factor is 2. So our b value is 1 over 2. So now from here, we're going to take this b value that we calculated, and we're going to put it as a coefficient right here in front of x. So we have h of x equals 2, parentheses, we have 1/2 x plus 0 plus 1. Now if you want to do some cleaning up here, you certainly can. You can write 2 times 1/2 x plus 1. But I want to be able to see that horizontal stretch that you added into your function. So here in example 2, we're going to modify a quadratic function. And this one says write a function g whose graph is horizontally shrunk by a factor of 1/4. So because this is a horizontal shrink, we're going to be multiplying x by some b value that we need to calculate. Now, our b value is calculated by using that factor. So we have b is equal to 1 over our factor, or the reciprocal of our factor. Now, if you're like me looking at that, that looks really messy. That is a fraction within a fraction. But what's really nice is we know from dividing fractions that if we're dividing fractions, so here we really have 1 divided by 1/4, when we divide fractions, we're really multiplying by the reciprocal of the second fraction. So that's something we learned back in algebra. So here our b value, if we have 1 over 1/4, becomes 1 divided by 1/4, which is 1 times 4 over 1, which is just 4. So our b value in this case is simply 4. So we're going to multiply our input value, or our x value, by 4. So here we have g of x is equal to, remember we're putting the 4 right here in front of the x, so we have -3 parenthesis 4x plus 5 quantity squared. And there we can see we've now incorporated a horizontal shrink of 1/4. Now if we look at the second example down below, this one is going to vertically shrink the graph by a factor of 1/5. So here we know that we're going to multiply the entire function on the outside by 1/5. So if we take our new function name, which is h, we're going to take the entire function of -3x plus 5 quantity squared. And what we're going to do here is, because this is a vertical shrink, we're going to multiply every chunk by 1/5. Now if you look carefully, you'll notice that this whole chunk is grouped together and there's no k value. If there was a k value in there, you would actually distribute that 1/5. But because all of these items are grouped together, we're just going to multiply this -3 by 1/5. Now for those of you that are a little rusty with your fractions and multiplication with fractions, remember that you turn every integer into a fraction. In this case, it becomes -3 over 1. And then you just multiply across. So in this case, it becomes -3 over 5. So our new function is h of x is equal to -3 over 5, parentheses, x plus 5 quantity squared. So you can see that we now have a vertical shrink of 1/5 into that problem by placing that multiplication of 1/5 right in there.